Welcome to the AMA series from GSD, the Summer Education Series. And let's start the session as always from the intro. Uh, I'm Binny, and we have with us Vinky as well. We both are from GSD, but we have a guest speaker today, and it's Lukas. Lukas, hello, how are you?
Hello. Good afternoon. I welcome you from the Czech Republic, from the sunny Czech Republic, and it's my pleasure to be here and answer your questions. So feel free to drop your questions, and we can talk about it.
Right. Thank you so much for being with us today, Lukas. And over to our slide on the platform that we're using. Anybody who has joined on our uh, series, summer educational series before, they know how exactly to use the platform. This is how it looks. We have the chat, polls, and hands out on your right hand side. Please make use of the chat session. That's hold as of now private, but at any point, if you have any queries or if you want to drop in the text or the queries that you are, which is basically we are all here for today. Please drop in all your questions and we would be catering to those questions. And at the same time, we have a list of questions which we have received from our customers, from mostly from the GCC region, on our help desk, and we would be dealing with that as well. So please feel free to share the questions that you have on our chat, and we would be answering to those questions. A bit on IDEA StatiCa, but I think since Lucas is already here, he's the best person to speak about IDEA StatiCa. So please go ahead, Lucas.
Yeah, thank you so much. So, who is IDEA StatiCa? So, IDEA StatiCa is an engineering company that is dedicated to developing of the structure design software. It's software for steel connection design, also for concrete design, not only connection design but also the member design. So we have like a unique solution that can help you out to verify, validate it, and code check your design, your connections, your concrete. Our solution is verified, is validated because we are closely cooperating with so many universities around the world, also in the US, also in the Europe, and we are great partners with the FEA and the CAT applications, like for example, the CI Engineer SAP 2000 ETAPS from the Fairword, and from the CAT softwares, for example, Tekla structures. I do believe that you know it. And every day, we have so many calculations, more than 10 million calculations annually. Yeah, this is the circle that is very well known for every structural engineer. We are trying to complement the solution that you already have. If you are a designer, you are using some CAD tools, some fabrication model drawings. You are using Tekla structures or Revit. So we have a BIM link to those softwares that can help you out to visualize and also deliver to your solution. And also for FEA, we have also the BIM link, the interoperability that communicate with your finite element model that you already have. So those are the structures or the solutions that we can providing you from the connection perspective. You can analyze or create very simple or very complex connections. From the member applications, that is the application that is providing you the solution for structures that are susceptible to losing the stability in general. From the concrete world, you can design and the code checks every discontinuity region, like depth and beams, walls with the big openings, also something from the bridge engineering, diaphragms. And also we have like a unique solution that's been released last year, and this is the combination between the IDEA StatiCa connection and the detailed solution that will help you out to design and the code check the anchoring, where you're able to insert the reinforcement inside the concrete block and to do the code check according to the wallet standards like a Eurocode and the ACI. So it should be the introduction about the IDEA StatiCa.
Right. Thank you so much for the intro. And a bit on GSD idea. So you know that GSD idea is the authorized result for IDEA Statica in the GCC region, and along with the primary technical support, we do provide the training and consultancy services here as well. So me and Venki, you already know that we are the product engineers at GSD Idea. So today, I will be hosting the session. I'll be asking Lukas the favorite questions from our end to IDEA Statica, and Venki will be with us supporting the chat questions as well. And just like you, we have 500 plus loyal clients all across the GCC. And yes, that would be a brief of the GSD idea and the activities that we do in GCC region. And with that, I am moving on to our topic today, that is the frequent questions. So the first question that we get asked on a daily basis to our help desk is that, is there a way how we can determine the maximum axial shear and moment capacity of a connection in IDEA Statica? So I'm looking forward to the answer from you, Lucas.
Yeah. So I think you already answered the questions because the analysis that we are providing inside this inside IDEA Statica is design joint resistance. This is the simulation that let me just take a screen. Okay, I will just take my screen. Yeah. So okay. So I hope you will see the empty screen.
Yes.
Perfect. 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 And let me to explain the first question in detail. What is behind? What you can imagine behind. So as you probably know, so if you would like to know the design resistance of your joint, it's always dependent on the portion of the forces that you already have, and you need to incrementally increasing the forces, the internal forces that are in the form of the internal forces on the every member, and we are increasing the forces and trying to reach some limit, basically some limit from the portion or from the point of view plastic strain on the plates, or utilization on the shear, tension, or combination in the tension and the shear. For anchors, we are also trying to find out the maximum in the tension and shear resistance, and also the critical points are the welds. So if the software comes up to some issue or some failure modes that is represented in this article, so he will stop the simulation and gives you the factor. The factor is represented here. So the factor is 134.4%. What does it mean? So if you multiply all the internal forces on the members by this factor, so you will find the critical failure mode that is based on those assumptions. So this is the goal of this simulation. It will basically help you out to find the vestigial resistance or the joint design resistance of the whole connection. So it's very worthy to test it out. So if you are using this simulation, you already know what are the limits, how it works. For those who are interested in, just go inside the IDEA Statica. So I will just show you where it is. If you just go to IDEA Statica, just select some connection. So I'm just starting IDEA Statica. So it takes a minute. Yeah. So do not forget to download the latest version. So I will just open up some connection and show you where you can find the joint design resistance, because there is like a plenty of the analysis that you can run. And one of them is the joint design resistance. So it's starting. Hmm. Okay, take some times because I have so many windows open, So okay, it should be processed quickly. Yeah, I mean, I will just move it on the other screen. Hmm. Yeah, it's here. Look, this is how IDEA StatiCa looks like in the version 25. So if you basically create the connection from the library or from the scratch, it's up to you, and you will just go to connection. As you can see, here are hidden the analysis types. Here is more than the joint design resistance. You can also turn on stiffness capacity design, and one of them is joint design resistance. So if you just reswitch it, you can just turn on the simulation and you will receive the output that I have already explained here in this article. I think this article will be shared with you. Um, Okay, so I hope it's the answer for the first question. What can I expect as the second question?
Yes, yes. So our next question,
Hmm.
let me just share my screen again
Yeah.
so that our attendees can see the question as well. Now, the second question that we get asked frequently, when I say this frequently, it's the most frequently asked question, I must say. What are unbalanced forces and how do they influence the connection design in IDEA Statica?
Hmm. Yeah, that's very essential questions. If you are starting with a design or connection design, that's very important to understand the basics. The basics, I mean, for example, the static equilibrium. The static equilibrium is a most important part from the import itself, or handling with the connections, and I will tell you why. So here is the brilliant article from the colleagues in the IDEA Statica that is explaining in detail what is behind the unbalanced forces and why you as a user need to have the forces under balanced condition. Yeah, so I will just share share my screen. Okay. Mhm. Okay. Look, here is the article that is very well explaining how our model is assembled and what is basically hidden behind, because you as a user cannot see basically the constraints that are behind the simulation. This is hidden for the users, but it's very important to understand. This is the reason why we just write this article. So at first, let me explain that here is the button loads in the equilibrium. Loads in the equilibrium is the button that from my perspective should be turned on all the time. Don't turn off this button and keep your model balanced. What are the boundary conditions that are behind the connection? So if you turn on the equilibrium, so there will appear something like a boundary condition. As you can see, three members, three nodes that are working independently. So here is just the boundary condition that is representing at the end of the beam for um, IDEA Statica model, but behind the constraints is implemented into the node, that is in the center of the joint. From the center of the joints is, as you can see, this part is visible, is also here, but this part, this invisible element, we called condensed element. This is the element that is basically elongated or is prolonged is prolonging the beam, the B1, for example, and the length is dependent on the height of the section. So all the forces or all the constraints that are implemented into the node are transformed till the end of the node. So what does it mean? So here are some backwards rigid links that are basically moving everything what is happening in the node till the end of the member, till the end of the condensed super element. This is very important. So if you import or applied the internal forces to the node to every member, these forces will be transformed to the till the end of the condensed element, and this condensed element is loaded at the end, and from this point it's coming back to the bolts, welds, and the plates, and basically loading up this connection. So here is just the example how it works. And as you can see, this is the equilibrium. The equilibrium for this connection has been reached, has been attained. So this connection is perfectly balanced, and you will obtain after the simulation correct results. What will How it works? So here is the nice outlining how it works. So if you apply this bending moment and this shear force to the node, what is happening? This shear force is moving from the left to the right to the end. So the shear force will be constant over the length of the beam. But the bending moment, as you can see, if you apply just the bending moment, it will have some like a constant shape of the bending moment, 60 kilonewton. But because the shear force is at the end of the member, so it will reduce linearly the bending moment, and you are receiving the bending moment like this. Yeah, so this is the goal, how it works and how we are applying the internal forces to the connection itself. You need to understand this principle to be able use IDEA StatiCa like correctly. Yeah, so this is the application, and let me show you what is happening if you apply or if you have this unbalanced forces. What is happening? This is the best way how to show to you what is happening if you have this connection. So as you can see, I have some nodes, and to the nodes are applied just the normal forces. You will apply 1, 2, 3 forces. Sorry, 1, 2, 3, 4. And as you can see, I have equilibrium. So it means this connection is loaded perfectly. If you run the simulation, so this is the trend of the normal forces from the beam elements. If you transform it to the IDEA StatiCa connections, those forces are going from the node, are going to the till the end of the members. The members are loaded, and it's going to the welds and also to the bolts. So you are receiving 73 kilonewton as a tensile force in the bolts. So right now, let's check what will happen if you have the unbalanced forces. If you have the unbalanced forces, the force here is just 98.6 kilonewton. Yeah, so this is just a warning for you that if you apply incorrectly, or if you basically break down this integrity from the point of view of the unbalanced forces, you are receiving also lower or different tensile forces in the bolts, and it's very dangerous. Yeah, so please stay by the internal forces that are under equilibrium, and do not jump out from this solution. So it's verified, it's validated. If you neglect our recommendation, it can cause some issue or underestimation of the connection design itself. So this is just the answer from me about the unbalanced forces, and how you should design the connection based on the static equilibrium that is coming from the 3D party softwares.
Right. Thank you so much. I think that was very beautiful explanation of how exactly to deal with unbalanced forces and basically where are they coming from as well. Now to our third question. So this is the third question. How are
Mhm.
non-conformities defined, and what role do they play in assessing the connection safety?
Mhm. Yeah. So that's the question that is really resonating a lot. Yeah. So that's also like very important and essential principle during the connection design. Let me just share my screen to answer this question.
Yes.
Hmm. Fine. Yeah. So this is the. I do believe that uh, you can see the slide.
Yes. Now
Yes.
yes.
Yes. Amazing. Amazing. Just give me a sec. I will share. I will share. Um, yeah. Non-conformities. Yeah, I do believe that this is the answer. So at first, non-conformities regarding the secondary forces. So if you are designing the connections, you have the option to apply some constraints at the end of the beam or at the end of the elements. um I think, just give me a sec. I will maybe share another better article. This one. Yeah, this is it. It's more transparent to show you what I mean. So those are basically the additional boundary conditions, or some boundary conditions that are causing some residual forces and restraining your model in that way that sometimes it can lead to some secondary forces. So you need to know what is hidden behind these constraints. So in the IDEA StatiCa, you have like a four options how to turn on the boundary conditions. If I just step into IDEA StatiCa, and you will just indicate the member. Here is the model type. We call it model type, but those are basically the boundary conditions that will be applied on the member. So as you can see, if I have a model type where all 6 degrees of freedom are available, are released, so you can, or you are able to apply all 6 internal forces. Yeah. So it means the member can be loaded in all directions, and there are no constraints basically in the node. And this node, there are no constraints. But of course, there is also the option to apply the boundary conditions that will restrain your model just in the plane. So it means the rotation in this direction is prohibited, is neglected, and it can cause another like a non-conformity from the point of view of the secondary forces. If you right now step into the load effects, as you can see, the shear forces, like in this direction, in the perpendicular direction to this I section, Vy, also Mz and Mx are basically restrained, and you as a user are not able to put in any other forces. Why? Because if we just allowed this input, all the forces are going to the boundary conditions and will be basically neglected. Yeah, so this is the reason why it's grayed out, and you are not able to put in any other internal forces. So just step into to the article where all the constraints are explained. um, the most resonating, I would say, question is about the motor type and VY, VZ, that is mostly, that you as a user will mostly use for one bolt connection. Why for one bolt connection? Because if you have just the one bolt connection, so here is just the perfect hinge at this point. And if you do not apply the boundary conditions on the element will basically starting to rotate. Yeah, there will be some kinematic motion, and it's not allowed because we are not using any dynamic simulation. We are just using the static simulation, just the standard implicit solution that we are not allowing the rotation of the member as a rigid body, for example. Yeah. So this is the reason why you need to apply some constraint at the end of the member to to basically force the member stay in the position that's in the like horizontal position. So yeah, it's very well explained here that at this position is pin. So if you just apply something, uh, if you do not apply the restraint, so your model will starting to be diverged, and you will receive the singularities that no forces has been transferred. So what you need to do, what you need to apply to force the software basically simulate this connection. You need to apply this model type NVY VZ. What does it mean? Those 3 degrees of freedom are available, so you can apply the internal forces. But all the rest, uh, internal forces, that like the bending moment in the one and the second direction, and also the rotation around the z axis, is restrained. So it means you're not able to bend it. There is zero zero rotation, so it's basically like a rigid boundary condition in the rotation, and it will allow you to apply these forces, like a normal force and the shear forces, and also force the software to make a simulation. If you Yeah, if you do it, so you will see what are the deformation. Here is really nice gif that is explaining that here, as you can see, here is the boundary condition, and if you just overscale the deformation, you will see how the bolts is basically deformed, or pins how are deformed, and also that we are allowing the rotation because of the constraints that are inside. Yeah, and because we applied some boundary conditions, and our system is not being anymore like a statically determined, but is statically undetermined or overdetermined. So it can you can reach, or you can see some non-conformity from the point of view of the global reaction. So because I just applied the bending moment at this direction, so I can see some deformation, and also the portion due to the stiffness of the plate that is here, some portion of the bending moment, or not the bending moment, but this moment around the global axis X, is going to the support, and it's basically brings up additional stresses in the plates. So you need to use these constraints with the wisdom that there can happen some additional non-conformity. Yeah, this is the principle, how it works, if you apply some boundary conditions, and your structure is starting to be overdetermined. Yeah, as you can see, yeah, this is also GIF and the deformation that's causing additional stresses to the plates. So the bending moment, or this not bending, but the moment in general, will cause some deplanation or deformation of the plate itself. Yeah. So this is the explanation of the non-conformities, boundary conditions, and how to use it wisely. Um, Also, we have like more examples that I can explain. If you have like uh, sim- section that is like unsymmetrical section, and if you apply the shear force, for example, for this U shape, we are always applying the force or the internal forces to the center of the gravity of the section. So what will happen with the section itself? So if you apply the forces um, in the center of the gravity and not to the center of the shear, it will be causing the deformation of the section, right? um, and yeah, if you would like to fix it, there is just a very easy fix, I would say. You will just apply or you have two options. The first option is to find the rotational moment and apply it also to the system, or you can use the constraint or model type NVZ that will basically bypassing the putting of the torsional moment on the section. So that's very essential. To be honest, to be honest, it's better if you apply these boundary conditions, and the moment will be um, distributed automatically, and you don't need to calculate the center of the shear and the the moment that will be stabilizing the rotation. Okay, so I think that's all from my side. If you are interested in more about this topic, I know that it's essential, so feel free to jump into this article, read it out, and if you have some comments, just feel free to drop it. Yeah.
Thank you so much for that as well. Because I must say about this article, I just read this article a few days back, and then it's a very explained article on the same issue and everything, based on how the model types are defined and how we need to uh, specifically on the model type, I would say. And
Yeah.
yes, a really beautiful article. Now, with that, just a reminder to our audience that the questions are being answered on the chat as well. But I'm going to proceed with the fourth question right now. And the fourth question is, what are good limits or rules of thumb for acceptable plastic strains in plates, bowls, and wells before the failure occurs?
Yeah. So let me just react on this question. So at first, the where where we get this 5% plastic strain. Yeah, for example, you know that in our application, we are just relying on this 5% plastic strain. That's the number that is rooted in the code. This number is coming from the Euro code in general, where for plate in that's are submitted to some load, you can reach 5% plastic strength if you, of course, ensure some compactness of the section. So it means if you have a section from the class 1 or 2, so you have like enough ductility, and you can go on the limit 5% plastic strain. Of course, if there are some sections um, that are going to the class 3 and 4, at first to the 3, you need to reach the elastic limit. Yeah, so you cannot exceed the yield strength. So there is no possibilities, or you shouldn't use it for plastic simulation, right? I'm just talking about the section, not in a connection itself, right? But it's also related to the connections, because the connection is created from the members, right? And if you have class 4 section, this section is susceptible to losing the stability, and you should always analyze the backlink together with the stress and strain simulation. I highly recommend to turn on the backlink for all the members, all the connections, to see what is the limit, what is the alpha critical for the simulation. So just if I come back to the 5% plastic strain, this limit is also we are using this limit for AISC code, and if you would like to know more why we are using 5% plastic strain also for AISC, because it's not hardly it's not hard coded in the code for AISC. We just taken over this value from the Eurocode, and the value, if I just share my screen. Yeah, uh, fine. Just share my screen. Hmm, yeah. So here is the article that is explaining why is 5% plastic strain limit used in material diagram for AISC. Yeah. So here is just the detailed explanation that is highly related to the stiffness that is encoded inside the AIC, and based on that, we just derived that 5% plastic strain is really safe value for designing of the connections. If you would like to know more, if you would like to more deep dive to the method and why we just used 5% plastic strain, I highly recommend to read out this article. And if some questions comes up on your mind, do not hesitate and basically drop the question and contact us. We will answer it in detail. But as I mentioned, this recommendation that we have as a 5% plastic strain is taken over from Eurocode and is applied also for AISC, but from the AIC, it's coming out from the moment curvature curve. Yeah, that is explained here. I do believe that I answered the questions. If not, just do not hesitate to drop the message, and we can discuss it in detail, or I can send you more verifications on that. Yeah.
Right. And at the same time, we can drop the links to the articles as well to the chat box. And
Yeah.
with that, I'm just going to share our fifth
Yeah,
question. And
maybe if I just can share just the one amendment, I would say,
mhm,
to this plastic strain for
right.
high strength steel.
Hmm.
We are in general considering 5% plastic strain for a standard. I'm sorry, you just taken over the screen, right? uh
Yes.
yeah, I will just take it back just
Okay.
for a moment. Yeah.
Yes, please, please. Yes.
Okay. Fine. Okay, just the highlight, yeah, about the high strength steel, because for high strength steel, the ductility is reduced for high strength steel. So this is the reason that based on this is also coming from the Eurocode. I'm just talking about the Eurocode. So here is the in the code setup, code and calculation settings. As you can see, the limit for plastic strain for high strength steel in the percent is 1, not 5. So we have reduced the value from the 5% plastic strain for high strength steel. Those are the steel materials that are exceeding 460 megapascal. And for those high strength steel, we are considering just 1% plastic strain to be on the safe side, because the ductility of in general of this material is reduced if you submitted this material to the tests. So this is the reason why we just reduced the plastic strain on the 1%. And this limit is also, I think, coming out from the code. So we have some support in the code, so you should be able to find it in the code. Yeah. Just to mention this part, I think it's important for the people that are working with a high strength steel.
Yes, yes, true. Uh, so can we move on to the next question, or would you like
Yep.
to elaborate? Right. Okay. So the fifth question is basically from our concrete application users, and it's on the compression softening effect. That's if that is considered in idea statica detail, or how exactly is it considered?
Yeah. So that's very good questions. That is very important for every structural engineer who is doing a design of the discontinuity region for concrete in general. Yeah. So if I just sorry, if I just take my screen, or I can just explain it on your screen.
Mhm.
Um, you know, what is the phenomenon of the compression softening? What we can imagine behind. So if you have some like a concrete wall or concrete element, and you have just a big portion of the compression in one direction, there is also the portion of the tensile strength or tensile strain on the other direction. And the concrete is not homogeneous material. So in the one direction, the concrete can bear in the compression a lot, but in the tension, there is just very small portion in the tension. So if you force this element to the big portion of the compression, so there will appearing something like cracks, in the perpendicular direction, and it leads to the lower strength of the concrete in general, and you need to somehow consider this effect during your discontinuity region design. And this is the reason why we just implemented the compression softening in the form that we are reducing the design strength of the material. If I will just take my screen. Yeah, I will share it. Yeah, I do believe that you can see my screen. I will just
Yes.
go right here. This is also a good way how you can search the information on our web. You will just type in the compression softening, um, and there are two planes because we have a software, IDEA StatiCa 2D detail and IDEA StatiCa 3D detail. So if I will go to the support center, here is the theoretical background. Here is the part dedicating to 2D detail, and this is to the part dedicating to the 3D detail. So at first, let me just jump into the 2D detail. In the 2D detail, here is the whole um, explanation and theory behind the 2D solution that we have. That is also split it for Eurocode, ACI, and Australian code that we have implemented. Um, this is very important part that Bini was introducing you on the slide. So this is the effect of the compression softening that is already implemented in the 2D detail in the solution that can transfer the load just in the plane, because we are supporting plane stress model. So it means the solution is highly suitable and fitting for structures that are basically the dimensions, the thickness is lower or is lesser than the other two dimensions. It's basically for the walls, everything what you can solve in the plane, this application is suitable for. But if you have something what is like a more general, what is more um, recalling the volume, or basically the all three dimensions are the same, or you would like to load it up the structure in all directions, so the solution in the form of the 2D detail that we have here is not suitable for. So so to come back and recap, for 2D solution, we already have implemented the compression softening. But for 3D solution, because we have started for 3D solution, the 3D solution, the 3D detail is the suitable solution for anchoring design right now, and the solution is verified. So it means for the anchoring design, the compression softening is not the biggest problem. Yeah, and we know it. We know that the big problem of the compression softening for this. I would say volumes, or for this general structures, is mostly for pile caps. There is the big portion of the shear that is basically causing big compression forces in the concrete, and there is also big transverse tensile strain. And if you neglect or omit this effect, you can have some the model can be, overestimated, and it leads to the results that are right now under the verification process. So if you stay by the anchoring, you will be designing the anchoring. So there is any other reason why you shouldn't use it. You can use it for every type of the anchoring, steel to concrete. It's perfectly fitting and working because it's verified. If you would like to use it for the other solutions like a pile caps, so be careful that this effect for 3D solution is right now not implemented, but this is in the process of the implementation and verification. So I do believe that this is the answer on your question, Bini.
Yes, yes, exactly. And I'm just moving on to our next question without much delay.
Hmm.
And it would be the sixth question. But I think this question you've already answered while explaining the non-conformities.
Yeah,
So I'm going
exactly.
to move on to the seventh question, and which is the best way to model the tapered sections in IDEA StatiCa. So this is a question that we get often asked from our prospects before taking IDEA StatiCa, just so that most of the sections that they want to create is a PEB based or a tapered section.
Hmm.
So how do we approach, or how do IDEA StatiCa approach this question?
Yeah, that's very interesting questions. So as you probably know, we haven't implemented the tapered sections, so you need to find some workaround. And there are like two workarounds that you can use. It's very dependent on the sections that you are using.
Mm,
If you are using, for example, you would like to model the tapered frame corner. So there is option to use you can assemble the tapering using some general plates. In the IDEA Statica, there are some manufacturing operations, and if you use the manufacturing operations, so here is the option to create the stiffening plate, or basically general plate, or if you or you can use some stiffening member that can basically substituting the part of the haunch, for example, in the bottom of the eye section. Yeah, so this is the possible, but for me, the recommendation for you is to the best way is to assemble this tapering using the stiffening plate and the cut operations. Yeah, you have some negative volume operation, and
mhm,
you can reuse it for cutting of the plates to create something that looks like this. Yeah. So this
mhm.
is those are two options that I can recommend. Here is also some sample project that is available on the web, and you can just reuse it and try to test it out if you want.
Right, sure. And also about a very different workaround that our customers use it in order
Hmm.
to replace the tapered section, that is to take the intermediate of the section and then do the connection design. So again, as an extension to the same question, would you recommend it, or is it like a safe method to do it, right method to do it?
Uh, to be honest, I know that the safe method that we are using the most, and what I'm aware of, is the using this general plate method. Yeah, that is
Right.
perfect. That is working, and I just tested out. Any other form, you can just try it, but of course you should verify it somewhere else on the other in the other software, for example.
Got it. Yes. Now that brings us to our next question. Uh,
Mm-hmm.
okay, so this is a very interesting question that we get asked often in our onboardings, the steel onboardings that we do to our very recent IDEA Statica users, like new IDEA Statica users,
Mm-hmm.
and they often get confused with this percentage load tab in IDEA Statica. So if you can explain what exactly is that and how can they use this tab in connection and the best effective
Yeah.
way, then that would be
Mm-hmm. Yeah. Yeah, in some countries, basically the structural engineers would like to design the connections based on the percentage or on the portion of the bearing capacity of the section. For example, they would like to design the connection based on the 50% of the bearing capacity of the bending bearing capacity of the section. So we in the IDEA Statica providing you the option to design it based on this approach. What does it mean? So if I just take the screen, um, if I just take the screen here, so I do believe that you can see that, and here is the load percentage. If I just so you can see this is my section. This is my section. Right now, I will just turn off the equilibrium. Please don't do that, but just for this intro to the question, if you just turn on the loads percentage, what does it mean? So let's say I would like to design my connection just for 100% of the my. Okay, so if you take 100% of the my, as you can see, the level of the moment for this section is recalculated from the sectional properties of the section. So what does it mean? So let's say go to the material properties. If you go to the material properties, as you can see here is IPE 300 360. So I do believe that this is the section. Yeah, IPE 360. Yes. So if you just go to this sectional modulus that is in the millimeter square, and you will take the yield strength of the material, and you will just multiply this value with yield strength, you will receive this bending moment, 362.7 kilonewton. Yeah, so if you just I will just take a screenshot. I will just look. Here is the IPE. This is yeah, this is 355. Yeah, so 355. So if I just go to the material properties, it should be based on the plastic bearing capacity of the section, right? So if I just take the screenshot like this, and let's say I would like to reuse the 100% from the bearing capacity of the section. So what you can do, this is just the, sorry for my typing, I because I have a mouse. So the standard equation for maximum sigma is my divided by wply. And if you know that your yield strength is s 355, and you know this plastic modulus, so you're able to calculate this moment. So if you multiplied those two numbers, So you should be able to receive the moment that is coming here. Yeah, so this is the explanation that you can basically reuse for your design. Let's say I would like to design the connections where I will utilize 50% of the bending capacity, 30% of the shear capacity, and 20% of the like a normal capacity of the section. So right now, I just put all the internal forces that I want, and I can just analyze. But maybe I will just exceed the bearing capacity of the section, because you need to multiply, you need to know if you apply those forces. So you need to calculate the the strength capacity of the section, if the section is able to carry this load. So this numbers or percentage just gives you the portion of the bearing capacity of the section in the axial shear and the bending resistance. Yeah.
Okay, so if I'm comparing this to our first question, wherein a user has asked if we can find out the connection capacity. So how would you relate this question? So this is just on the section. So had there been two or three members, and can we define each capacity for the each section, and then would can we run the analysis
No,
accordingly?
no, this is not like that. So the capacity, or basically the joint design resistance, is like a independent solution. This is just the this solution that you can see right now is just the form of the inputs, right?
Okay,
What you can do to the what you can do on the members. This is
right,
nothing like the bearing capacity of the whole connection. If
connection.
you would like to analyze the bearing capacity of the whole connection, and you have like multiple members that are tied up to one node, so you always need to go to the connection, and you need to just run the joint design resistance based on the forces that are already here. This is just the form of the inputting of the variables, or inputting of the internal forces. That's it.
Understood. Okay,
Yeah.
right. Yes. Thank you so much for the clarification.
Hmm.
And I'll move on to our next question, which is a bit on the stiffness part in the connection application, another analysis. And the question
Yeah.
is, how does IDEA Statica classify connection stiffness, and how does it relate to the real world structural behavior? So basically, how can they take it back to the global structure, and then compare the results from IDEA Statica stiffness analysis?
Yeah, just I think the very brief and handy instruction is coming from the outlining of this graph. So we are supporting basically two stiffnesses that are also related to the code. That's very important that we always are aligned with the code. This dashed line, as you can see from the graph, it's representing the moment curvature of or moment curvature capacity of the connection itself. But of course, on the path, as you can see, the path is non-linear, because we are using non-linear components. So you can see that there is some critical, or some significant point that is like a 66% of the MRD. What is the MRD? MRD is the resistance of the connection itself. So it takes into account all the components, like plates, bolts, welds, everything. So if your internal forces, or yeah, if your bending internal forces are under this value, under 66% of the MRD, you can use the initial stiffness that is basically independent on all the other combinations. If your bending moment will be basically higher than 66% of the MRD, you should take into account the second stiffness that is dependent on the combination itself, and will be different for every combination. So this is, it can be a little bit like a problematic if you would like to, if you would like to um, you know because you have like 100 combinations, and for every combinations that is exceeding this 66% of the MRD, you should use different stiffness. So it's impossible to put it into the global FEA. So there is also the third option that you can use. You can use the nonlinear spring. The nonlinear spring, which will have this moment rotational curve that is the dashed line. So if you just go through IDEA StatiCa, you will just run the stiffness analysis. So you're able to export all the values from the increments to the Excel spreadsheet, and you will be able to display also the nonlinear curve, and this nonlinear curve can be inputted into your global FEA. And right now, if you have this nonlinear curve and you have this assembly of the connection, so you can apply it every other loads or every type of the loads that is in your global FEA, and you will always receive the reasonable stiffness. Yeah, so from my perspective, this is the best way, but you need to turn on in your global FEA the nonlinear simulation to be able to capture this nonlinear trend on the curve. But the first step is, or the best way, and the most easiest part is to run the stiffness analysis, and you can use the initial stiffness if it's under the 66% of the MRD. If it's not, you can decide if you will use, for example, the minimal stiffness from all the combinations. If it's over if it's exceeding this 66% of this MRD, and you have multiple combinations, so you can it's basically engineering judgment right now. Yeah, there is no like straight solution that you should be applied. It's always dependent on the engineer that is driving the simulation. Yeah, so and if you would like to have the, from my perspective, the best solution, but it's you need to run the nonlinear simulation in your FEA, you will use this nonlinear curve that is coming from the IDEA StatiCa, and you can apply, and you will receive all the time the proper stiffness for your simulation. So this is just my recommendation from the experience during the using the application. So I would like to share it with you.
Thank you so much. So with that as an extension, I have another question. I just struck me when one of our users asked this question, that
Hmm.
how do we deal with unbalanced forces when it comes to the seismic analysis? So when we have seismic analysis forces,
Yeah,
then there would
we are
be
not handling.
unbalanced forces.
Yeah, basically, right now for we have a solution that is called capacity design. In the capacity design, you are not using the forces from the seismic, but you are able to calculate the maximum based on the pre-qualified joints. Okay, so this is just the one type of the simulation that you can use for seismic design. But to be honest, if you are using the seismic simulation time history analysis, and you are just converting the forces from the seismic to some equivalent forces, we know that there is also some shaking on the left and on the right. So, and we are just summing the forces under the square root, because we are using SQRS combination, square root
Yes.
response spectrum combination. And if you will use it, you will lose the information about the sign. So that's very problematic, and right now there is not proper solution inside the IDEA StatiCa, um,
Okay.
because of the combinations where you are just losing the signs. We just in I think in 1 or 2 months, Andrea from the USA, she will be talking about the seismic design using the um, StatPro. And in the
Mhm.
Stat Pro literature, or in the Stat Pro theoretical background, there is just the method that is very well known in between the engineers in the US. I do believe that also for most of the engineers that are using the AISC. And there is just the method that can be used in the Stat Pro that is automatically considering the sign for the combinations based on the dominant mode. So I highly recommend to watch this webinar, and maybe these questions will be answered there. But for all the
Okay.
other softwares, this option I do believe it's not available. This option is available just for Stat Pro.
Mhm.
Um, so if you have a Stat Pro and you are using this, just the seismic design, you know this option. For those who doesn't know, maybe it's worth it to review and check the webinar.
Understood. So that was a part of my question. Now the
Mhm.
second part of the question is that, so if somebody wants to manually adjust or manually balance the forces just to bring it to equilibrium, how should he do it? Should that be based on individual stiffness of the member, or is it like equally distributing all to all the members? So which would be the right approach?
There is no right approach. You're not able to balance it. Yeah, so that's
Yes.
not possible. Yeah, that's not possible because it's based on the some thousands or millions of the equations that are coming from the structure. And if you have some unbalanced forces, how you will apply it to the member, what portion, I don't know. Yeah, so that's very hard to say. And you can just try it based on the stiffness, but there is no straightforward solution. And
Solution.
solution that we recommend in the IDEA StatiCa, we always recommend to have it under balanced. And this balanced solution is coming from the implicit solution from the like a static solution, not the dynamic. Yeah, so this is
Understood.
like it is right now.
Right, understood. And could you please let us know when exactly we are having that a session on the Stat Pro? Uh, if you have a specific date, then I would like to
Yeah,
mention
I
it
would
on
love
chat.
to. I would love to, but I think the date wasn't set up right now. Yeah, so
All right, all right, uh,
I will let you know during if I will know the date, and you can
right.
just spread it in between the
Yes,
users.
yes,
Yeah.
yes. Sure, sure. Yes, definitely. So moving on to our next question, can we or do you need a water break, uh, or
Yeah.
can we proceed?
Maybe some just 2-3 minutes break. I will
Two,
just
3 minutes. Yes,
yeah,
yes, please. Yes.
have some water.
So, right, yes. So in the
Yeah.
meantime, I would like to answer one question that has been in our support and also in our social medias. Where do we find the latest news on IDEA Statica, and where do we find the quick uh, solutions or quick news from Idea Statica? So for that, we have a news for our GCC users, whoever is seeing it. We have two platforms right now that GSD provides. One is the YouTube platform wherein we post all the videos, basically all the webinar videos, and we're also planning to keep the summer series videos as well, but it's under discussion. And here is where you will find our YouTube videos. If you go to the Google, all you have to do is to just type GSD idea, and then you will find our YouTube channel. And this is our YouTube channel, and we have posted all our webinars in here. So please make use of this YouTube tutorial to for your future references, be it parametric template or about the bulk import option from Stat. We have this, and also for all the engineers who is using Idea Statica in the GCC region, Gulf region, we have a GCC user group. Now this is where we post all the news about Idea Statica, be it the latest versions, be it the latest patches, or the uh, updates or the major updates on the software, whatever it is, and also on the trainings that GSD Idea do from our end. Everything would be notified here. So this is the group. So if you want to join the group, please request access to the group, and then we are more than welcome to let you into the group if you are a GCC based Idea Statica user. And yes, that's how you can get the news from GCC. uh, so I think we are good to go for the next question. Can we proceed with the next question, Lucas?
Yeah, sure. You can
All
just
right.
Ask me the question.
All right, thank you so much. And the next question is: can we model through bolts in concrete?
Yeah, right now I think the answer is simple. At this version, we are not able to do that. But in the future, upcoming versions, I can't promise like in what version it will be delivered, but it's in the scope, so it will be delivered in the next versions.
Right. Yes. And the next question again. Oh yes, this is a very complicated question, and then this comes often to our help desk. So if you have multiple base plates, then we need to
Mhm.
definitely coming from different direction. Then definitely we need to define multiple base concrete bases as well. So how does IDEA Statica internally considers this multiple concrete blocks? Is it treated as a single one, or is it treated as a multiple concrete block on its own? So
Yeah,
yes.
that's very important question. So there are like two plans how to explain the question. So it depends what solutions you are using. If you are starting from idea statica detail from the scratch, or if you are using import from the idea statica connections. If you are using idea statica from the scratch, you can basically define one concrete block, and you can attach so many base plates you want, or how many faces you have. Yeah. So if you are importing the concrete concrete block, or you have like a multiple connections that are, or multiple anchorings that are coming from the IDEA connection. So you always in the connection need to use more for like a more concrete blocks, or you can just connect it to the one concrete block. And if you import it, there is the option in the IDEA Statica 3D detail that we released like last version. Let me just share the screen, because we have added the boolean operations, right? And the boolean operations, the boolean operations yeah, here. So the boolean operations, I do believe that you can see that this article enable to create something like a cut or the merge. Look, you have basically two concrete blocks that are in the idea sticker connections, and you would like to export it to the 3D detail. So you will export it, and you need to use the operation that is called merge or the cut. Basically, the operation should be visible here. Yeah, if you use the operation cut, there is not written internally, but there is also the merge. Yeah, there is a slash merge. So it means if you will use it, you can merge more concrete blocks together and create one concrete block that we allow you to analyze. Yeah, so I highly recommend if you would like to know it. So here is in the support center, we had a webinar that is also related to this topic, and it's frequently asked questions. It's been in the steel connection, or maybe steel three, no, not the steel 3D detail. Yeah, that's been, yeah, this one. 10 most frequently asked questions for 3D detail, and I think the 10th question is about the merging of the blocks. Yeah. So if you would like to,
I think we have a small disturbance on the connection from Lukash's side, but I believe that he'd be back very soon. Hey, Lucas, are you with us now?
Hello, hello. Can you hear me?
Hey, hello.
Hello,
Yes, we can hear you. Can you hear us?
hello, hello.
Can you hear me?
Uh,
Can you hear me now? Hi. We can see you, but I think you're muted, so we can't hear you. Uh, I think if you unmute, then we'll be able to.
hello, hello, hello.
Hi, hello.
I'm not muted. Uh,
Can you hear us? Just in the meantime, while we are fixing this, while he is fixing it, if you have any questions, please drop them down. And Venki is already on a chat, so he would be definitely answering to your all questions. And in the meantime, I'll just check with Lucas that what's happening. So please give me a minute as well. We will be back very soon.
oh, can you hear me?
Hi, Lucas. I can hear you. Can you hear me?
Yeah, right now it's good. There's
All
some
right. Yes. Yes.
for that internet maybe.
All right. And the platform is also a bit new to you, so might
Yeah.
be a. I understand, but finally we are sorted. So we were at the concrete merging
Hmm.
option. So that
Yeah.
was the last that we heard from you.
Yeah. I hope that you can hear me. Can hear me well.
Yes.
Yeah, I think the last questions has been answered from my perspective.
Right.
You need to use
Yes.
the cut operation or the merge operation to merge it to have a one concrete block, because at this version or yeah, because at this version we are not able to calculate more than one concrete block.
Understood. Right.
Yeah.
So can we jump to the next question?
Hmm. Yeah, we
Right.
can.
So the next question, so the previous question, question number 12, was basically the same with an extension. You already explained it to us, that was regarding the merging option in IDEA Statica. So I'm jumping to the 13th question. And what is the
Hmm.
difference between 2D and 3D CSFM? So when somebody is new to IDEA Statica and when they open the concrete application, they can see 2D detail and 3D detail. So
Yeah.
just for them, if you could explain in short that where do they stand, then I think it would be good.
Yeah, that's a great questions. It's very important questions. So let me just share my screen. I will just show you in the application
Yes,
where you can use it for. Okay, so I will just share it. Jump in here and open up the detail. So, if you step into to the detailed solution, to this discontinuity region design, you are able to select 2D solution that is based on the plane stress, and you are able to apply just the load in the like a plane direction or in the vertical direction, in the one and the second direction. I mean, vertical and horizontal. You're not able to apply it out of plane forces. Um, so this is how it looks. So if I just select the 2D solution, the use cases that can be that you can use it for are just the walls, are the beam or tapered beam with the openings. You can use it also for the pre-stressed beams where are just the multiple openings. You can use it for frame corners. You can use it for corbels. If you are bridge engineer, you can use it for pier caps. You can use it also for just the foundation or basically concrete blocks that are loaded just in the plane and don't have so big transverse direction. I mean, it's not like a solid, it's more like a wall. So that is just the limitation that you need to you need to understand, that all the loads has to be applied just in the vertical or the horizontal direction. Out of plate bendings, out of plane forces are neglected. And the sigma z direction or sigma z stress is neglected because it's a plane stress solution. So it means sigma z is equal to 0. If you would like to use the 3D solution, we highly recommend this 3D solution for the anchoring right now. So if you have every type or any type of the anchoring, and you are using IDEA StatiCa connection, or if you don't using IDEA StatiCa connections, you can use it from the scratch. Use it for anchoring design. If you have any other solution, you can of course use it also for the other discontinuity regions that are basically somehow coordinated or distributed in the space, but we are relying on the verification and the validation, and the solution is verified and validated for anchoring design. In the future, you will be able to solve also the pile caps and typical or yeah, the similar solutions for the pile caps. But we are trying to go step by step to bring you the verified solutions, that we are always guaranteed that it's verified and it's validated, and this is our guarantee basically. And for anchoring design, it's verified and validated.
Yes. So,
Yeah.
just as an extension of the same question, I have question number 14. I'm not sharing my screen so that you can
Hmm.
explain it more. Uh, so, this is again another question that's frequently asked, which is how should the results from 2D and 3D be interpreted? So,
How should we interpret? Okay, yeah, you mean the outputs post processing
yes,
in general,
exactly.
right?
Yes,
Yeah, yeah,
in
in
2D
general.
and
Okay, okay,
3D.
okay, okay. Hmm. Yeah. What outputs you can expect from the solution? So, okay. Uh, yeah, it would be maybe better if I show the results in the application itself. Yeah, I will do that just for a 2D solution. Yeah. Okay. Look, if I just open up some detail at first in the 2D, later on in the 3D, we'll calculate it and explain it in the detail, because that's very important to understand the outputs. Fine, I will just take detail. The outputs are the same for both codes, ACI, Eurocode, and also for Australian code, that are already implemented in both versions, 2D and the 3D solutions. So let's take something what will be calculated very, very swiftly. So let's say, what about the wall? Yeah, so just take the wall. I will just run the simulation to receive the outputs. So there are just differences between the 2D and the 3D solution. In the 2D solutions, we are also covering the serviceability limit states. So it means that you can, yeah, I will just run the simulation, and we will get the results soon. So, but beforehand, let me just explain what type of the results you can expect. You can expect ultimate limit state results, strength in the concrete, strength in the reinforcement 3 bars, and the anchorage check. It means it will gives you information if your rebars will be pulled out from the concrete, or if your bond between the concrete and the wall, or between the reinforcement rebars and the wall will be broken. But of course, we are giving you also the serviceability limit states. It means like a stress limitations, deflections, and crack width. Those are the code checks that are at current version not possible to display in the 3D detail, because there we are supporting ultimate limit states only right now. So let's go to the strength. In the strength, you can just display this sigma c. What is it? This is a compressive stress, and or this is the principal stress under compression, because we are supporting the concrete in the compression. What is in the tension is in the concrete neglected and is basically substituted by the reinforcement rebars. We know from the real experiments that there are some small portion of the concrete in the tension, but the code is saying that concrete for ultimate limit state in the tension is neglected, and we are following this rule, so it's there. Also, the reinforcement. In the reinforcement, you can just display the strain on the rebars and the stress. So those are the two outputs that you can get out um, from the rebars. What about the anchorage? Anchorage is very interesting output, because the anchorage gives you two information. The first information, because there are two failure modes that can happen. The first failure mode is that your bond between concrete and the steel is broken, basically. Or the second failure mode is that your reinforcement rebars will be basically ruptured. But this failure mode is also captured in the strength of the reinforcement rebar. Yeah, so this is those are two coaches that are also available in this bond. But you can display, here is so many options what you can display. You can display the bone stress. The bone stress is represented in the tab and is compared with the design bone stress that is coming from the code. It's dependent on this on the class of the concrete. Yeah, you can of course display the total force in every rebar. So if you are doing that, you can expect the forces that are coming from the integration of the stresses along the length of the rebar. So for example, here, as you can see, the force in the rebar is 23.2 kilonewton. If we just step into the stress limitation, the stress limitations, what you can expect from the stress limitations. If you just go to the calculation and you will just go to the chapter 5, chapter 7 for reinforced concrete, chapter 7 for pre-stressed concrete, chapter 5. I would like to talk mostly about the reinforced concrete. So as you can see, for chapter 7, we are controlling the K1 for characteristic combinations, so it means longitudinal cracks. Also for linear creep, we have quasi-permanent combinations. If you establish the quasi-permanent combination, we are controlling this 45% of the FCK. So it leads to the fact that the structure will be deformed under the creep linearly. Yeah, so there is just this is called linear creep condition. If you have this K3, this is for 80% for characteristic combination for reinforcement rebars. And yeah, this K5, this is for pre-stressed tendons that's right now are not inside the wall. So if I just check the stress limitation, as you can see, the code check is written here. The C2 is a combination characteristic. C3 is the combination. C2 is a quasi-permanent. C3 is combination characteristic. How did I recognize that? It's based on the sigma limit that is 0.6 FCK, and C2 is 0.45 FCK. Of course, I can change the long-term and the short-term behavior. Another combination is a crack. the crack width for quasi-permanent combination, that's very simple. It's controlling the crack width on your structure based on the reinforcement ratio or a number of the rebars that are inside the concrete, and you are able to step into the deflection, and you can say that your total deflection is 20 millimeters if you turn it on. So you can just assign the limit, and the limit total is compared with the total deformation. As you can see, there is just the 1.5%. If I just change the limit, my percentage will be changed also. So this is just the 2D. This is just the 2D detail. In the 3D detail, basically the solution is extended into the space. So the outputs are similar, but not the same. Let's say, let me just go to 3D solution. I will just use this anchoring, this predefined template. If I just omit all the explanation about the app and just jump into the post processing, before that, let me just go to the mesh and change it to the 5 to have it really fast. The outputs. So I do believe that it will take like a couple of seconds to get the results out of it. But before we just step into the outputs, you know, if we are in the 3D, so we are relying on the principal stresses. And the principal stresses are not just in the 2 directions, but are on the 3 directions: sigma 1, sigma 2, and sigma 3. Sigma 1 is the maximal principal stress under tension. It will be always, not always, but it's the most is the stress that is the most close to the tension. You know, if you have the Mohr circle, it's better if I just explain it here on this example. Yeah, because the 3D solution can be more complicated. If I will go to the support center here, to the theoretical background and 3D solution, right? So look, yeah, this is it. So this is the shear, and this is the normal stresses or the principal stresses. This is just the deviatoric plane, and this is just the meridian plane. Sorry, this is the yeah, this is the principal stresses, and here is the sigma 1 minus sigma 3. This is the shear in general. So if we are in the space, so you can see that we can outline 3 stresses: sigma 1, sigma 2, sigma 3. The sigma 3 is the most compression stress. This is what we are comparing with the compression stress, with the design compression stress. Of course, this value has to be somehow modified, because we need to recalculate it to the uniaxial stress from this triaxiality. This sigma 1 is the stress that is basically the minimal compression stress, I would say, and the sigma 2 is a middle stress that is always in between sigma 3 and sigma 2. Yeah, and this is the limit, this dashed line, for friction angle equal to 0, because we are using the Mohr Coulomb theory. And if we reach this value, we are starting to be you know, on the plasticity. So there can happen some portion of the plasticity. If you reach the limit, we are just stop the simulation and say that you reached the limit in the compression. So I hope that we have outputs. Yeah, we have outputs. So let's go to the check. And in the check, what you can expect. You can expect the summary overview of all results, concrete reinforcement anchorage. If I just, yeah, if I just, you can see that those are the concrete cones, or this vector form is a displaying of the stresses under compression. If you go to the strength, so in the strength, what you will see? You will see this sigma 3 that is recalculated to the uniaxial stress. We call it sigma equivalent principal stress. if you would like to know how it's recalculated from the sigma tree or from the principal stresses, please step into the theoretical background that I was using for explanation of the Moore column circle. If you just step in there, here is the at the bottom. At the bottom, there are just the outputs. I do believe it's there. Yeah, I do believe it's here. Yeah, yeah, and this is the equivalent stress. Yeah, it's a sigma C3 minus sigma C1, and you will basically get this this FCD. What is the equivalent? What is the equivalent stress? Uh, this is how it works. I will just come back to the application, and as you can see this minus 6.9 megapascal of sigma effective. If you will go to reinforcement, it's the same as in the 2D detail, but it's it's expanded to the 3D dimensions, so you're able to see the stresses on the rebars that are in the space. The anchorage, it's always the same. What's other differences that we are using the anchors mostly for this 3D solution. So it's always worthy to check this anchorage, because this code check is mostly limitation in the IDEA StatiCa connections, because there is used plain concrete, and if you put inside the reinforcement 3 bars, you will see that your concrete cone can basically survive, or your structure can survive, and your concrete cone will not be limitation for your design if you are using the plain concrete in the connections. So I hope that I articulated properly. In the connection, we have a solution based on the plain concrete, and if the code checks for concrete breakout are not passing, it's always worthy to export it to 3D detail, put reinforcement inside, and run the simulation and see if your anchorage check is passing or failing. And yeah, in the auxiliary, you're able to turn on the deflections that are very worthy to check as the first output, because if the structure is wrongly supported or insufficiently supported, so the structure can move as a flexible body basically, and you can have really big portion of the motion. Yeah, that can basically, you can just check if your structure or concrete block will be turned over or not. So those are just very shortly the explanation of the results. So I do believe that's more than enough for this question.
Definitely, yes. Actually, my intention of asking this question was to brief on the reports, but then you explained it in detail. Thank you so much for that. But
Mhm.
not just for this, but for your time in giving us this one. I know that we have only asked for your 1.5 hours, but we have exceeded the time as well. So thank you so much for giving your time and your additional time as well. We know that you would definitely have other meetings to run to, so we are pausing our AMA right here for today, but we have another session of AMA on our coming session as well.
Mhm.
So with that, we would like to end the live Q&A, and just a few ending slides from my end. So I'm just going to share my screen for the rest of the slides. It is on the resources and the technical support, and most of them Lucas has already covered it. So if you want to know anything about the theoretical background that IDEA Statica uses, or the tutorials from IDEA Statica, or even the webinars that IDEA Statica posts, everything would be here on the IDEA Statica support center. Lucas just explained how to go there, find the articles using the search words, keywords. You can also find that. So make use of that support center really well. And for other technical supports, for all technical support, you can always reach out to the local contact, which is a GSD, and via this email ID, support at gsdidea.ae. If we couldn't answer it, if it has to go to the HQ, then we would be sending HQ the question, and then they would responding to it, which we'll be reverting back to you. And again, the type of advanced training that GSD provides, and our focus is to is for everybody to know about the software, to get the hands-on training on the software. And these are the hands-on sessions that we provide to the users on the connection part, on the member design part, and on the concrete part as well. So if you would want to know more about the advanced training that we provide, please do visit the GSD Idea website, wherein we have in detail provided the modules that we would be covering, and then you can request for a advanced training there as well. And what is next on our summer educational series? We have on this Thursday, we have a session on anchoring and stability sensitive member application, which is again at 10 a.m. as a training session. And next Tuesday, we have a session on the steel onboarding. And again, as the last session, we would be receiving the rest of the questions from this session. And we would be adding more questions from our clients to complete the AMA. And we deeply value the feedback that you provide to us. And please scan the QR code to let us know about what you think about our summer series session, and on how do we present the articles. But if you want more on the trainings as well, you can place a request via this QR QR code. So, with that note, thank you so much, everybody. But very thankful note to you on behalf of GSD, Lukas, for your time and for all the questions that's been answered.
It has been pleasure. It's been pleasure to assist and help you out with the questions.
Right. Thank you so much. And thank you, everybody. And see you on the next session.
Bye bye.